Bubble sort algorithm for image recognition. Bubble sort is the simplest sorting algorithm that works by repeatedly swapping the adjacent elements if they are in the wrong order. Also known as sinking sort, exchange sort. A sorting technique that is typically used for sequencing small lists. It starts by comparing the first item to the second to the third, and so on until it finds one item out of order. It then swaps the two items and starts over. The sort may alternate from the top of the list to the bottom and then from the bottom to the top. Example 51428. In the first pass, 51428 becomes 15428. Here, algorithm compares the first two elements and swaps since 5 is greater than 1. 15428 becomes 14528. Swaps since 5 is greater than 4. 14528 becomes 14258. Swaps since 5 is greater than 2. 14258 becomes 14258. Now, since these elements are already in order because 8 is greater than 5, algorithm does not swap them. In the second pass, 14258 becomes 12458. Swap since 4 is greater than 2. As you can notice, in the second pass, only one exchange has been done. Now, the array is already sorted, but our algorithm does not know if it is completed. The algorithm needs one whole pass without any swap to know it is sorted. In the third pass, no swapping has been done because all numbers are already sorted from lowest to highest, which is 1, 2, 4, 5, 8. Now, this is the PHP code for the bubble sort. As you can notice, the sample output, which is the original array, is 3, 0, 2, 5, negative 1, 4, 1. The sorted array is negative 1, 0, 1, 2, 3, 4, 5.
So, have a good day, Miss. This is Janine Kit Beruan from Section A, and I am the second one to report about algorithm. Algorithm for image recognition. Image recognition is the ability of a system or software to identify objects, people, places, and actions in images. It uses machine vision technologies with artificial intelligence and trained algorithms to recognize images through a camera system. It is a technology that is capable of identifying places, people, objects, and many other types of elements within an image and drawing conclusions from them by analyzing them. Different tasks that image recognition can perform. The first one is classification. It is the identification of the class, the category to which an image belongs. An image can have only one class. This is the example of classification. We are pretty sure that there are only a dog and no cat. The next one is tagging. It is also a classification task but with a higher degree of accuracy. It can recognize the presence of several concepts or objects within an image. One or more tags can therefore be assigned to a particular image. This is the example of tagging. There are both a dog and a duck. The third one is detection. This is necessary when you want to locate an object in an image. Once the object is located, a bounding box is placed around the object in question. The example of this detection is, we know in which box in the image the duck and the dog are. Like you can see, this is the example of detection. The fourth is, and the last one is segmentation. This is also a detection task. Segmentation can locate an element on an image to the nearest pixel. For some cases, it is necessary to be extremely precise, as for the development of autonomous cars. This is the example of segmentation. We have the information at the pixel level. So the face of the dog and the image of the dog as a pixel. And this one is the example of image recognition to identify multiple objects in the picture. Like you can see the classification, and the classification plus the localization has the image of the cat. It is a example of single object. And the next one is the object detection and instant segmentation, which has a dog, cat, and duck, which we call multiple objects because there is many animals in this image. So the next one to report is Jensen. Thank you.
So, good evening everyone. My name is Jensen Estelorito, and for today, I'm going to report some of the image recognition algorithm.
This is the example video of image recognition to identify multiple objects in the video. Please watch.
Image recognition roadmap. An image is fed to the system. Second, conversion into numerical values. Numerical values fed to the system. Training sets with labels applied. Pattern identification in each image applied. Feature extraction in each of the image provided. Image recognition and material accuracy. And lastly, retraining model for accuracy improvement. So best example for this is Google Lens. If you use Google Lens, you'll just use your phone's camera to search for things. Algorithm used in image recognition: scale invariant feature transform, SIFT; speed up robust features, SURF; principal component analysis, PCA; linear discriminant analysis, LDA. So number 1, scale invariant feature transform or SIFT. It is an image descriptor for image-based matching and recognition developed by David Lowe on 1999 to 2004. This descriptor, as well as related image descriptors, are used for a large number of purposes in computer vision related to point matching between different views of a 3D scene in view-based object recognition. So basically, it will take photos from different angles to recognize what is the object. Major advantages of SIFT are locality. Features are local, so robust to occlusion and clutter, no prior segmentation. When we say robust, it is the quality or condition of being strong and in good condition. Distinctiveness. Individual features can be matched to a large database objects. Quantity. Many features can be generated for even small objects. Efficiency. Close to real-time performance. So SIFT is very reliable to use. Extensibility. It can easily be extended to a wide range of different features types, with each adding robustness. So, the second is speed up robust features or SURF. It's a fast and robust algorithm for local similarity variant, presentation, and comparisons of images. The main interest of the SURF approach lies in its fast computation of operators, using box filters as what you have seen in the photo, thus enabling real-time applications such as tracking and object recognition.
And now let us proceed to the speed up robust features, SORF. It is a fast and robust algorithm for local, similarity, invariant representation and comparison of images. The main interest of the SORP approach lies in its fast computation of operators using box filters, thus enabling real-time applications such as tracking and object recognitions. We also have here the advantages of SORFs. It includes approximate or even outperforms previously proposed schemes with respect to repeatability, distinctiveness, and robustness, yet can be computed and compared much faster. Strong performance and reduce the time for feature computation and matching and increasing simultaneously the robustness. The SURF descriptor outperforms the other descriptors in a systematic and significant way, with sometimes more than 10% improvement in recall for the same level of precision. Principal Component Analysis, or PCA, is a dimensionality reduction method that is often used to reduce the dimensionality of large datasets by transforming a large set variables into smaller one that still contains most of the information in the large set. Advantages of PCA are: it removes correlated features. In a real-world scenario, this is very common that you get thousands of features in your datasets. You cannot run your algorithm on all the features, as it will reduce the performance of your algorithm, and it will not be easy to visualize that many features in any kind of graph. So, you must reduce the number of features in your datasets. Improves algorithm performance. With so many features, the performance of your algorithm will drastically degrade. Reduces overfitting. Overfitting mainly occurs when there are too many variables in the dataset. And so, PCA helps in overcoming the overfitting issue by reducing the number of features. Improves visualization. It is very hard to visualize and understand the data in high dimensions. PCA transforms a high-dimensional data to low-dimensional data, 2 dimensions, so that it can be visualized easily. Linear discriminant analysis, or LDA, is used as a tool for classification, dimension reduction, and data visualization. And the last part of our slide is the advantages of LDA, which matters that it is a simple, fast, and portable algorithm. It still beats some algorithms like logistic regression when its assumptions are met. And that would be all. Thank you.